We have dreamt about building super tall skyscrapers ever since the dawn of time. The race is on, and we're constantly breaking new records. There's seemingly no end to our innovation. But is there any limit to how high we can go? In today's video, we will answer that question and explore some of the most visionary skyscrapers. Before we continue, make sure to hit the like button and subscribe to Deep Thought. Let us know in the comments below which superstructure you liked the most. What stops us from building higher and higher is certainly not our imagination. However, one of the major challenges that engineers are facing is the building's foundation. The soil supporting a tall superstructure has a limit to how much weight it can carry. It has to be able to support the enormous vertical and lateral loads. Even more importantly is to take into account the tipping moment. A tall building catches a lot of wind, and this creates immense stress on its foundation. In physics, this is called a moment. The foundation has to be able to support these enormous moments to keep the building from actually tipping over. Another challenge is the material. Every material has its strength. With concrete, you can go up to a certain height. With steel, a little more. If we want to build far beyond our current capabilities, we would have to invent other construction materials. These need to be stronger and lighter. In theory, you can avoid this by expanding the building area to create a very large support system. We would end up with giant pyramid-shaped structures that could reach up to virtually unlimited heights. And that brings us to the last major obstruction: economic viability. The visionary proposals that were actually accomplished found a way to yield profit. Somebody needs to be willing to invest and break the record. One thing is sure, the race is on. People are attached to the idea of being the biggest, being the tallest. Records are being broken, and new plans are already approved to break them again. The front line of this epic battle is currently in the Middle East, where the tallest building is already standing undefeated: the Burj Khalifa. With a staggering height of 828 meters, this epic construction is the crown jewel of the Persian Gulf. It is 3 times taller than the Eiffel Tower and twice the size of the Empire State Building. The building offers luxury residential apartments, office space, a 5-star hotel, and the highest observation deck in the world. At the top, you can overlook 95 kilometers of oil-rich desert. It took a total of 6 years for the construction to be completed. At its peak, 12,000 employees were working on the building each day. The weight of the concrete that was used is equivalent to 100,000 male elephants. The total weight of the aluminum is that of 5 Airbus A380s, and a mesmerizing 22 million man-hours were invested to its success. The Burj Khalifa is the undefeated champion of the world, but plans have already been approved to break the record again. In Kuwait, a proposal has been submitted to construct a building that would be the first to exceed 1 kilometer. In Saudi Arabia, the construction of a building has already started that will break even the record of Kuwait. That there is no limit to the human imagination proves the visionary megaproject Exceed 4000, a tall superstructure that would forever change the skyline of Tokyo. 6 kilometers wide, 4 kilometers tall, and counting more than 800 floors, the entire structure is a completely self-contained city. The design comes from a Japanese construction firm and intends to show a futuristic vision of engineering and of human evolution. The building has a capacity to hold between 500,000 and 1 million people and is fully serviced with a network of magnetic trains. The building is powered almost exclusively by solar energy. Inside, there are large parks with lush natural decorations, and the air is regulated to control the air pressure at high altitudes. There are large commercial spaces and residential areas for people of all stripes. The estimated cost of construction? That's somewhere between $300 and $900 billion. This is, however, not even the tallest building ever proposed. Introducing the Tokyo Tower of Babel, the pinnacle of dreaming big. Imagine the full height of Mount Everest, with the Burj Khalifa built on top, and it would still fall a couple of 100 meters short of the Tokyo Tower of Babel. With an imagined height of 10 kilometers, it would be 2.5 times higher than the Exceed 4000. The ground area would occupy a space twice the size of Luxembourg, and unsurprisingly, it was never meant to be built. The first plans for this megastructure were proposed in 1992 by a Japanese firm, and it was intended as a publicity stunt. The firm estimates that the construction would range between 100 and 150 years and would cost $20 trillion. In comparison, for that money, you could build the Burj Khalifa 13,000 times. But you would need another $6 trillion to pay off the US national debt. It becomes economically unviable to build beyond a certain height. That is, unless you completely rethink the way we build. The launch loop was first described in 1981 and was intended to revolutionize the way we launch people and cargo into space. The idea is to build a launch pad in space in the form of a tube that is attached to the Earth in two places. A spacecraft is carried into space from there and propelled into orbit. The tube would be constructed at an altitude of 80 kilometers and would measure 2,000 kilometers in length. Most designs feature a cable transport system that uses magnetic levitation, similar to the technology used for bullet trains. Going into space using a rocket is expensive and polluting. The advantages of using a launch loop are abundant. The spacecraft would only need to take the fuel it needs to maneuver in orbit. This would revolutionize our designs for space travel. The system isn't inherently polluting and could accommodate several launches per hour, independent of weather conditions. There are several engineering challenges that have to be overcome. For example, we don't currently possess the technology to electronically control the magnetic levitation. There are also several structural challenges, and the current designs are unstable and unsafe. And, of course, there's a hefty price tag. Keith Lofstrom, spiritual father of the launch loop, has worked out several financial scenarios, the cheapest of which requires an investment of $10 billion with a one-year payback. This would cut down launch costs to $300 per kilogram. One of the launch loop's competing designs is the space elevator. It's exactly what the name suggests, an elevator going up to the biggest penthouse in the universe. The concept has long been presented in popular imagination and was first officially proposed in 1895 by Russian scientist Konstantin Tsiolkovsky. His original design forms the basis for decades of improvements by scientists worldwide, and we're actually getting closer to making this dream reality. The elevator would consist of a strong cable that is attached to the Earth on one end and a massive counterweight in space on the other. Because of the Earth's rotation, the counterweight is pulled outward by a massive centrifugal force, keeping the cable steady and in vertical position. Attached to this cable is a climber, a cable car that could be used to deliver cargo and people into space. The major challenge that engineers are currently facing is to find material that is strong enough to sustain the colossal centrifugal force. Throughout the years, many different materials have already been proposed. The discovery of carbon nanotubes in 1993 put it on the short list of potential materials for the cable. More recently, in 2014, scientists synthesized diamond nanothreads for the first time and caused global excitement amongst scientists eager to get an elevator to space. In 2018, a broad group of space professionals came together and assessed the current status of the space elevator. They published in a joint statement that the development of a real-life space elevator is much nearer than most think. The day that we actually defy gravity and build a construction that reaches into space might be upon us. What do you think about these super tall structures? Let us know in the comments below. If you enjoyed this video, make sure to hit the like button and subscribe to Deep Thought. Thank you for watching, and we'll see you in the next video.